Here with David Brumley from Forallsecure, who's they're new folks that have coming to CanSec West this year and have some interesting stories and interesting products actually that we're going to be talking a little bit about with Mr. Brumley. Hi, David. How are you doing?
I'm doing great. Happy to be here.
You think we've caught you in you're on the road right now, so you've managed to cobble together a pretty impressive studio actually on short notice for this. Do you want to tell me a little bit about what happened? How did you get into all this, and how did we wind up with Forallsecure?
Yeah, it actually kind of goes back to maybe 1998. So I actually started off as the computer security officer at Stanford before that was a title that anyone cared about. And I got really interested in how attackers come up with 0 days. There was actually a story that really is the origination story. So I was there trying to trace down attackers, right? Like after a machine gets broken into, you try to figure out where all they connected to and then go notify those people and help clean up. And I remember there was a machine that was broken into. It was called medium.stanford.edu, and it literally was owned by a Nobel laureate. And the reason that I remember it is I had told him the previous week it had been broken into, and he needed to reinstall and install the latest patches and all that goodness. And he literally is like, I don't want to upgrade because I'm trying to uncover the secrets of the universe, and I'm not sure the software runs on the latest version of Red Hat. And there's some truth to that, right? But I won the argument, and here it was a week later, and I was going to have to go back to him and say, just installing those upgrades wasn't enough. And what had happened is someone had found a 0 day against SSH. And so they broke into this machine. They started scanning the Stanford network. Actually, one of the machines that got broken into was google.stanford.edu at the time. This was when it was still a research project. And so I got the pleasure of turning off google.stanford.edu once. And
I don't think a lot of people say I turned Google off once. Yeah,
I turned Google off once. Yeah,
the best I did was Mexico. So okay, another story for another time.
Both very impressive. So I got really interested. Like, how do attackers find these exploitable bugs? How do you find 0 days? And so I went back, got my master's, my PhD, and I spent like really 20 years, and I built a research project around how do we take a compiled program and how do we come up with exploits, things that will actually result in like control flow hijack? And we did binary code analysis, because the security audience here knows, right? An exploit is an input to a program, and low-level details matter. You don't really exploit a source program when it's like C and C++. It's always the binary. And so we built an automated tool to do this, and we started to apply it at scale. And about that time, DARPA had this idea of, hey, what if we could do fully autonomous cyber? We're able to do fully autonomous cars, fully autonomous robots. Right now, we have this huge workforce problem, and offense has the advantage. What if we can make a machine that can do what like hackers do at DEF CON CTF? And so they set up this, essentially a DEF CON CTF where machines played, and they call it the Cyber Grand Challenge. And we formed Forallsecure out of all our university research to compete in that. And maybe we were greedy. There was a $2 million cash prize, and we wanted to make sure that we won that cash prize, and it went to us and not the university. So that's why we formed the company. Nice. And we ended up competing and winning, and there's, every team that competed was amazing. And it was really cool because Mayhem actually played in the DEF CON CTF after that. So we got to see kind of where state-of-the-art machines versus human were. And after that contest in 2016, we did a little bit more maturing, but then we decided to productize it. We said, hey, look, this idea that there's a cybersecurity expert shortage isn't going away. And what we showed is once you move to a more modern approach, like you can Dockerize an app so you can give it to a machine, then a machine can check it, not just for exploitable bugs, but also do kind of boring things we think of in security, like regression testing. And although they're boring, they're absolutely critical. It's usually the main blocker for getting out a patch. It's not, was it vulnerable? It's, did that patch break stuff? And so we're automatically building that. And so we've been selling this as a product for a while, and we just opened up like a freemium version of it and just growing every year and learning not just about like what are the best cybersecurity techniques, but really that kind of motion of how do you get businesses to adapt new technology.
So here's a strange question. So do you guys build your product into, do you foresee people putting it in their CI chains and having it just kind of automatically be part of like all their builds? And is that or is this more sort of run one shot kind of a thing, or and get a report?
Yeah, this is ran as part of a build. So It's kind of a different process, actually. So one of the things that historically people have done is they said, as part of build, we're going to have a security scan. And it's always boggled my mind why people think that, a 30-second or 3 hour security scan is going to find all exploitable bugs that no attacker, these great guys at Pwn to Own like Fluorescence are going to miss. There's really two parts to this. So part of it is running continuously as part of your CI/CD, and what you're running is regression. Has every exploitable bug that Mayhem has found so far, or fuzzing has found so far, has it been fixed? The other important thing to check is whether good test cases are still good. Google reports something like 40% of bugs they were finding in Google Chrome are regressions where someone added a feature. So that's part one, you're running it in your CI/CD. But the other part of this is in the background. Mayhem is a little bit like a bot, and it's just continuously trying to do a pen test. And so it's a little bit different than like static application security testing, where there's this bot that's continuously learning and it's dropping and finding new exploitable bugs, just like an attacker would, where those can now get fixed as the developer does their agile development or whatever their process is. And so it really is like an extension of this idea of just one scan. It doesn't stop there. You do that one scan, but then you continuously run in the background because it's just a CPU cycle, exploring and getting deeper.
So you're kind of like, am I getting this right? You're kind of like an API fuzzer, basically. You're continuously toggling the external, except without the instrumentation that the fuzzer would do for code coverage and stuff. You're using if I'm understanding right, you're using clever techniques to get at the target rather than just blind go for everything like a fuzzer would, trying to tickle all the code bits. Is that a good paraphrase of it?
That is. So what we were doing in research, really, I'll explain it kind of at two levels, a technical level and a high level, right? So at the high level, when we run the code, we have a dynamic binary instrumentation. So we watch the code as it executes. So we're watching x86 or x86-64, ARM or PowerPC or anything that we support. Okay. And we're watching the instructions and we're using an execution and we're learning from that how to come up with an input that triggers a different code path. So technically, this is called symbolic execution. As you execute the code, you can think of there's an if-then statement. If x is greater than 2, go to the left. If it's less than 2, go to the right. If x is even, if x is... And so we build a mathematical model of that. And then you can give it to a SAT solver to solve for inputs that take you to code branches that you care about. And so if you kind of think about it, all an exploit is, if you want to make it trivial, is a test case for a corner case in the code. Yeah. And so Mayhem, like anything, is trying to get code coverage, but it's doing it not based on random inputs or anything like that. It's using state-of-the-art satisfiability solvers to try to drive inputs to previously untested parts.
That's pretty cool. Okay, so you guys are showing up at CanSec West for the first time, and I think you guys. There's one thing I wanted to chat with you guys. I think you just came back from University of Arizona, or you guys and you guys are sponsoring some students and to come to the conference. That's really an awesome effort, because I'm always trying to figure out ways to get new and get folks from younger generations interested in this area. Can you tell me a little bit about that?
Well, I think part of it's our DNA. Like, I'm a professor, so teaching is part of who I am. My co-founder was my PhD student, so teaching is part of who he was at, right? In addition to research. So we've kept this in the culture. So we started doing really university tours. And we went to Carnegie Mellon first. We had 160 people actually show up on a Saturday. We went to Arizona State. We had 450 people registered, which was over room capacity. So we had to waitlist people for, on a Saturday, like, free training. And what we're trying to do is really teach people either security or DevOps, because people don't seem to know both. So we're going, for example, at universities saying, like, look, you have these great security courses, but this is why people use Docker, and this is a GitHub action, because no one's ever teaching these sorts of things that are part of really modern software development. So we're doing that. And then when we talked to you, I came to you and I said, look, typically when you sponsor something or something like that, you can get some slots. All I want to do is sponsor student scholarships and then teach the world more about how to secure their software. And so we sponsored a bunch of them, and we're really happy that it worked out. And I think it's the right thing to do, right? We have this shortfall. We need better automation techniques, but we also need people to bring their creativity.
So yeah, it's actually funny you should mention that because you guys, your product seems to fill that role. Everybody's hiring right now. It's a great time to get into the security industry if you're a young person watching this. Uh, but so automating our one hope for solving some of this shortfall of people is to automate. So see if I'm understanding this right, you guys are kind of bridging some of the work you did in the academic world and bring it to the commercial world, but you're really tooling up some of that stuff that used to be done by human analysts with all this. Is that a fair estimation of an advantage here?
That's the ambition. So this DARPA program, the Defense Advanced Research Project, right? It's to show the art of the possible. So they showed self-driving cars were possible 20 years ago. But then it takes a while to turn that kind of art of the possible into you've solved all the engineering problems for working with people's languages and the current operating system environments, documentation and integration with, for example, GitHub, right? Like all those kind of odds and ends that are engineering that are important. And so that's what we've been working on with the idea that, look, finding exploitable bugs is very similar to just like a chess engine exploring different moves. And so that's kind of like an analogy of what Mayhem is doing. And you can have machines do that at machine speeds. And also you can just take advantage of cores. You can scale it up and run it on 1,000 cores if you want to get even deeper. And that really frees the human to do what they do best, not exploring states in a program, but being creative.
I've spent the last 2 weeks wading through old PHP and JavaScript code, and that actually sounds automating some of that. As I've done that, I think that's everybody's been chasing some of that. One of the things that strikes me about your approach, though, is that you guys are you're doing it at the binary level, right? So you're not dependent on idiosyncrasies of PHP and configs or Java object serialization or whatever it is that it kind of seems to work across. It's a broad swath of across everything, right?
We started with binary analysis because it did allow us to just hit a large swath all at once. And there's really two reasons. So one is like binary exploitation is just cool. And when you look at kind of like what does it take to win Pwn, it's all binary analysis. The second reason is because you're actually looking at the code that executes. We're not tied to the developer participating. So when we started this research, right, usually it's developers that are in charge of the security, and everyone's like, developers need to understand security and they need to fix the problem. But it's not the developer who pays the price when something has a vulnerability. Just going back to my story, like at Stanford, I was a sysadmin, a CISO, going around trying to fix machines. I wasn't the developer. And so we wanted to democratize this a bit. And so we made some leaps and bounds here where people are actually analyzing code that they use, but they're not the author of, just to determine the safety.
And so this sounds actually really cool. I'm working on a project right now. I'm going to recommend this to somebody. It's a free version. You guys recently released a new cool thing. Please tell me about it.
We have two actual things that are interesting. So first, if you go to forallsecure.com, we now have all versions of our technology available for free for open source projects. So what we mean by open source is not a particular license. It's just a public project on GitHub. Okay. And so we integrate tightly with that where we can be we have an action where it can be part of CI/CD. You can always do a one-off if you want, but we really like the continuous operation mode. And so anyone can use it. We've actually gone kind of a step beyond that. So I read this story where if you go talk to actually open source developers, the reason they do that is because they love the creativity aspect of it, or creating new code, or just learning new things. None of them want to do security. In fact, if you ask them, are you doing security? They say no. And you say, do you want to do security? They say no. They want someone else to do it for them. And so we've also created with the open source, we paired this with something we call Mayhem Heroes, where if you integrate an open source project, we'll pay you $1,000.
Oh, wow. That's pretty cool. That's got to be, and you're removing pain, because I mean the reason they don't want to do security is because it's a hassle, right? You've got to go contact all these people. It's not the kind of thing that you like to do when you're a coder, right? You got to do all this juggling, notification, blah blah blah. There's a lot of overhead to it. That's a really cool effort. I did not know about this, so that's kind of awesome.
Developers want help. So we've architected it right where you can actually have a security person who forks the repo, does all the integrations, and we'll submit it back to the original developer. really trying to not just incentivize it with money, because money, open source developers aren't necessarily incentivized by money, but basically just a small reward and pairing that person who's interested in security with the open source project developer, and then trying to get them to work together.
And okay, I got one last question, because I'm actually thinking this in mind for my my customer that I want to recommend. So for folks that aren't open source, like, is it a licensing? Tell me a little bit about the commercial end of it. Is it a per seat licensing? What's it kind of look like for a customer of yours?
So the way we price Mayhem is by the number of CPU cores you run on. So we thought about doing like per user licensing, but most companies only have one user. It's called Jenkins. That would run this, and so nice. It didn't really work. So we decided to price it. It's an annual recurring license. So we are a product company. We don't do customized services as much, and we'll install either a private SaaS instance for you, so you'll have like your single tenant SaaS, which a lot of companies like, or for an additional fee, we have an on-premise version of it. And so it's no secret, like after we commercialized this, I think the DoD created a $45 million contract for us to check, for example, weapon systems. And we're using automotive and those sorts of places where they really put things on isolated networks.
Yes, because when things go boom, when things go wrong there, and those are a little more important. Yeah, how much cool. That's awesome. Well, thanks so much for spending time with me today and telling me about this. This is awesome. It was very informative, and we'll see you all in Vancouver in May.
Awesome. Thanks for having me. And I'm looking forward to meeting everyone in person, especially the students who have our scholarship.